Thanks for watching this presentation of MakeCap Power, XNets and TPoints Part 2. In this example, we're going to look at T-points and T-point topologies and an example of DDR pin pair timing using T-points for branched pin pairs, XNets, and illustrated using MakeCap Power's Visualize Visualizer. Before looking at T-points, let's look at topology, of which T-points are one aspect. The topology is the path a signal follows when it's routed for a three-point net. These are the various combinations that you could specify. Constraint Manager is not concerned specifically with topologies. It's concerned with time of flight between 2 points on a path. So if we have various topologies, the Constraint Manager timing will overlay on top of those topologies as a separate operation. So if we have a time of flight between A and B of 5, depending on the topology that's underneath and supporting that, we may end up with various constraints that look like this. So what's a T-point and why do we care? Well, T-points are virtual pins, is a way to think of them, that are used to specify pin pairs. T-points can only be defined as part of the process of defining a larger topology in PCB Editor. You cannot define a T-point in the Capture Desktop outside of a topology. So just as with XNets, in order to use T-points on the Capture Desktop with MakeCap Power, you would first define T-points in PCB Editor, and then once those are defined, they'll be visible and available for the use in pin pairs in MakeCap Power. In order to create this kind of topology, you need to use one of the several methods in PCB Editor, either user-defined topologies or creating topologies in SIGXP and then storing those in EC sets. DDR memories are often routed with a branching set of paths, and a T-point is often used to be able to constrain the timing from the driver to the T, from the T to each of the memories, from the driver all the way to the memories. This display was extracted and created within MakeCap Power by the Visualize Visualizer. Let's create a star pattern of pin pairs that's typical of DDR using XNets, T-points, and even illustrating how bubble up and pin pair work in the Capture Constraint Manager flow. So I'm going to select a series of XNets in the min-max propagation delay screen. That's going to open up our min-max propagation delay form, and you can see these are identified as XNets. And I'm going to go into the Enhanced Pin Pair display, where each of the XNets is shown graphically. There's the name of the XNet, there's the name of the two nets in the XNet, and there's the series component that joins the two together. Rather than individually create these pin pairs, we can use the sort components process within MakeCap. So MakeCap has distilled out all the components that are in all these XNets and shown these in a list which I've sorted alphabetically, including the T-points. And we want to create these pin pairs from the C to the T and from the T to each of the U's. So we're not going to use the actual series components to create any of these pin pairs. So I'll highlight and delete them from our list, and that will delete the pins that we're going to be working with. And we're going to select Define Star Pattern. And now we can see a listing of all the pins in each of the XNets without the series resistor pins. And if we wanted, we could choose each of the T-points as the branching point. We can also get a distilled view just of the components. And so I can in one step just select the T-point, and it will map to all of these XNets. And all of the pin pairs have been created automatically. from the C to the T and from the T to each of the U for each of the XNets. So I'll say OK. And this will populate our form where if we wanted we could put in min and max delay values and create rules. But we can also do this visually. So I'll go to Visualize. And now we get a visual view of all the pin pairs that we've just created. And to help make this more clear, I'll do a sort on all the pins, and I'll select just the C pins that are standing in as the driver pins in this example, and they're all highlighted. And I'm going to pull them over to the other side. So if I zoom out, I can see there's my pin pair star pattern. And now what I want to do is I want to select just the pin pairs from the C to the T points, and I want to put some min-max values on these guys. Again, I could do this with data mining, but I'm just going to show it to you graphically right now. They're all selected. I can go to Apply Rule. I'll set these up as mils. I'll put a minimum of 500 and a maximum of 750. Say OK. And if I zoom back in, I can see that these values are now visible on the selected pin pairs as well. I'll go ahead and write these now to the form. So the form's been fully populated. I'll say OK, and I will have created all of those values ready to go into Capture and subsequently flow into Constraint Manager. If I do a sort on the XNets, since Capture is a net-based tool and Bubble Up requires similar values on all the nets in the flow, I can see that for the VD0 XNet, both of these nets now have individually the same pin pair defined redundantly with the same min-max, so that when this flows into Constraint Manager, there's no conflicts between the individual nets in the XNet and their pin pair values and the XNet already defined in Constraint Manager and what it'll see when we netlist forward. If I look in the easy view, I can get a view also that's very similar to Constraint Manager, and so I can see for net VD0 this pin pair has been created and it has a min and a max value.